All right. I'll try to go without my notes done. Hello, everyone. My name is Patrick Balestra. I'm a staff engineer working on developer experience at Spotify. And today I'll be talking to you about improving CI efficiency with Bazel querying and bazel-diff. So first of all, let's talk a bit about Bazel at Spotify. We're currently trying to move all of our clients to build with Bazel. The first clients to be completed are all of our iOS applications that can now build with Bazel. Soon we should be able to also build all of our Android applications with Bazel. And we also have C++ and TypeScript code bases that are shared between some of these applications that we are soon also going to move to Bazel. Our goal is to move all of these repositories to a single client monorepo, which could host more than 10 million lines of code, 150,000 tests, run over 1.5 million CI builds every month, and receive 8,000 commits a month from various hundreds of engineers. So when we started thinking about this possible client monorepo, we foresaw some challenges. One of these challenges, of course, are continuous integration scale. So this is a simplified version of our dependency graph. We have Android applications, iOS applications, and a shared C++ code base, and then a desktop app building for multiple platforms, and also a web component that ships in there. So if we focus on one of the parts of our monorepo, such as the iOS part, we realize that we could have, as I said, tens of apps, thousands of components, thousands of test targets. And so whenever a developer wants to write a new test, for example, for our full lib tests target, we don't want to rebuild the whole monorepo. We don't need to build our Android code. We don't build our shared C++ code, also because some of these parts of the monorepo build on multiple platforms. So we don't want to waste time checking out the repository on a build agent that doesn't really need to do anything. So effectively, our problem statement becomes finding which Bazel targets are affected by a specific diff. And this is a question that has come up more and more on the Bazel Slack as well over the last couple of months. You just don't need to do this kind of like finding which Bazel targets are affected by a specific diff only for improving your CI efficiency, but also to kind of find out, what do you need to redeploy from your monorepo, or many other answers that you could get. So there are various tools to solve this problem. One of them, of course, is Bazel querying that comes with Bazel. You could run a query, you could run a C query, and use functions such as rdeps and our build files to find the set of affected targets. Benjamin in 2019 gave a very nice talk at BazelCon, and also someone from Pinterest, I believe, in 2020. So if you want to learn more about this approach, you can, of course, look at these talks. And then in 2020, bazel-diff was open sourced by Tinder. It kind of abstracts away a lot of these issues that you would have to figure out yourself. And it supports query, C-query, and also the stream proto output format, which is a very efficient way to parse even gigabytes of proto messages coming from Bazel. And then in 2022, Target Determinator was also released. It currently only supports C-query, I believe, but it's a very similar idea to bazel-diff. So you can go ahead and experiment with these tools and kind of find out what works for your use case. I'll be focusing a bit more on bazel-diff in this talk because this is what we use at Spotify, but it's also what. But I also believe that a lot of the things that I'll be talking about are tool agnostic. So some of the ideas should be reusable for all the other tools. So let's talk about bazel-diff a bit. Bazel-diff supports two commands. The first one is a generate hashes command. What this does is that it generates a hash map representation for the entire Bazel graph and writes it to a JSON file. In this case, starting hashes.json. So you can see the list of targets on your as a key, and the value is a SHA-256 that represents all the attributes that go into that specific target, including all the inputs. So what we then do is that we change revision. So we check out our different commit, for example. We run the same exact command and output the hash map to a final hashes.json now. And we can start to see that the hash is different for the same target. And so we then run the last command available in bazel-diff, which is going to get our impacted targets. And so here we have, again, our target full lib tests that change between the two commits. The bazel-diff repo contains a great example script that you can just use and try to experiment in your repositories. So it should be really fast to see some example outputs. So now that we understand how we can find the impacted targets between two revisions, we can put this information to use to improve the efficiency of our continuous integration builds. So in this image, we can see that we have a simple continuous integration pipeline. So we could have, a task that builds our iOS applications, another task that builds our Android applications in Linux, and then, even more tasks that build and run our tests on different platforms. In our client monorepo, if we were to merge all of our repositories today, the list of tasks could be over 100. So we, of course, want to reduce this number to a minimum. So first of all, what we do whenever a developer pushes a change to our repository, we run a diff task. And this runs exactly the same logic that we just specified. So we can then find the impacted target in the change submitted by our engineer. So what we then try to do is that we try to introduce a simple YAML file that defines the conditions in which subsets of our pipeline should run. What I mean by that is that, as you can see, releasable apps is running a query, right? So we want to run a query to find all the releasable targets in our monorepo. So in this situation, we see that we have an iOS application and an Android binary. So if in the intersection between the query that we have specified in our YAML file and the list of impacted targets that we got back from bazel-diff is empty, it means that effectively it's safe to skip these tasks and we can just ignore them on CI. We continue to run the second query. In this query, we're trying to look for all the iOS unit test rules that are in our repository. In this case, of course, we just have one target as an example, and we see that there is a valid intersection between the two lists. And so it means that we actually need to build our tests and run them on iPhone and iPad to validate the change submitted by our engineer. So as you can see, we simplified quite a bit the initial pipeline to only run the subset of tasks that are strictly necessary to validate this specific change. Also, in order to better understand and communicate to our engineers what's going on in our CI, we do display this information in a GitHub check. And we also are pretty explicit on what kind of CI tasks we can skip as a result of this system. So we call this system build avoidance, and we have seen at least a 30% reduction in our build agent usage. This is mostly because we can reduce our cloud costs, but also provide a faster experience to engineers who are contributed to maybe just a smaller part of our monorepo, and we don't need to rerun everything else that is maybe more expensive. Here are some tips after using such a system for a couple of years. Of course, this is a Bazel query, so you can trust it for changes that happen outside your Bazel dependency graph, such as bumping your Bazel version or changing Bazel RC flags. So bazel-diff comes with a really nice feature, which is called seed file paths, which accepts a list of files that, if changed, will invalidate the hash for your whole repo, so effectively causing everything to rerun again. Bazel-diff also has a couple of flags to customize the behavior of your query, so you can kind of like improve the accuracy and performance of the query if you need to do so. And if you're interested about this kind of stuff, last week we published a blog post on our engineering blog where we talk about how we moved our iOS application to Bazel. So if that interests you, I encourage you to take a look at the blog post. And yeah, please find me later for questions, and thank you.